Shielded Metal Arc Welding SMAW. Hello folks, welcome to this comprehensive lecture on shielded metal arc welding SMAW. In today's session, we will delve deeply into the fundamentals of the SMAW process, discuss equipment setup and operation, and cover basic welding techniques and essential safety measures. This lesson is designed for employees in a company setting who are eager to understand the intricacies of SMAW, also known as stick welding, and enhance their practical skills in this widely used welding technique. Introduction to Shielded Metal Arc Welding SMAW. Shielded Metal Arc Welding SMAW is one of the most widely used welding processes due to its versatility and simplicity. It employs a consumable electrode coated in flux to lay the weld. The electric current is used to strike an arc between the rod and the metal workpiece. The heat generated melts the workpiece edges and the core of the electrode, forming a molten pool that cools to form a strong joint. In this section, we shall explore the fundamentals of the SMAW process, which include understanding the components and principles behind SMAW process fundamentals. Electric arc. The primary principle behind SMAW is the creation of an electric arc. When the electrode contacts the work metal surface and then pulled away slightly, it generates an arc that produces intense heat necessary for melting metals. Consumable electrode. The electrode serves dual purposes. It conducts electric current and supplies filler material for the weld joint. It is coated with flux that helps stabilize the arc and protects the molten weld pool from atmospheric contamination. Weld formation. As the heat melts the electrode and workpiece, a weld pool forms. Upon cooling, this molten pool solidifies, creating a strong metallurgical bond. Slag formation. During welding, the flux coating decomposes and covers the molten metal, forming a layer called slag. This layer prevents oxidation and contamination. Slag must be chipped away after the weld cools. Equipment setup and operation. Setting up the right equipment correctly is crucial to successfully implementing SMAW procedures. We shall look at major components involved and how to correctly set them up for safe and effective welding operations. Essential equipment for SMAW. Welding machine. This device provides the necessary electric current. There are alternating current AC and direct current DC welding machines, each suitable for different materials and conditions. Electrodes. Various electrodes are available, made from different materials with specific coatings. Selected based on the metal being welded and the desired characteristics of the weld. Electrode holder. A clamping device to hold the electrode securely while conducting current to it. Ground clamp. Connects the welding equipment to the workpiece to complete the electric circuit. Personal protective equipment (PPE) includes helmets with face shields, gloves, aprons, and boots to protect from the intense light, heat, and spatter produced during welding. Setting up the equipment. Connect the ground clamp. Attach the ground clamp to the workpiece or workbench to ensure a secure connection, completing the electrical circuit. Insert the electrode. Secure the appropriate electrode in the electrode holder, matching it to the base metal type and thickness. Select the current type. Choose AC or DC current based on the materials and electrode requirements. DC is preferred for stability, while AC may be used in certain environments. Set the amperage. Adjust the machine's amperage settings according to the electrode type and diameter, ensuring adequate heat for proper fusion without overheating. Basic welding techniques and safety. Once the equipment is set, it's vital to employ the correct welding techniques to create high-quality, durable welds. Understanding and practicing these methods will ensure effectiveness and consistency in your welding ventures. Key techniques in SMAW. Striking the arc. Begin by tapping or scratching the electrode against the workpiece to initiate the arc. With practice, you'll maintain a stable arc without sticking. Maintaining arc length. Keep a consistent gap between the electrode tip and the workpiece, typically equal to the diameter of the electrode. Adjustments may be needed based on position and type of weld. Travel speed. Move the electrode along the joint at a controlled speed to ensure proper penetration without burn-through. Travel speed influences the width and appearance of the weld bead. Weaving patterns, different patterns, for example, straight, zigzag, circular, help control bead shape and penetration. Choose the pattern based on the joint position and requirements. Safety measures and SMAW. Safety is paramount in any welding practice. Adhering to recommended safety standards protects not only the welder but also those working nearby. This section outlines critical safety guidelines that should be followed during SMAW operations. Safety precautions, personal protective equipment (PPE). Always wear appropriate PPE like helmets with proper shade lenses, flame-resistant clothing, gloves, and boots to protect from sparks, UV radiation, and molten metal splatter. Ventilation. Ensure adequate ventilation in the welding area to avoid inhalation of harmful fumes and gases. Use extraction systems or work outdoors if possible. Fire safety. Keep flammable materials away from welding zones. Have fire extinguishers readily available and be familiar with evacuation routes in case of an emergency. Electrical safety. Regularly inspect all electrical components for damage. Use insulated tools and wear dry, non-conductive gloves to prevent electric shock. Training and supervision. Ensure operators are well-trained and understand all equipment functions. Supervision is crucial, especially for new welders. Understanding shielded metal arc welding SMAW thoroughly involves grasping its fundamentals, mastering equipment setup, employing effective welding techniques, and adhering to stringent safety measures. Keep practicing and referring back to this guide as you develop your skills in SMAW. Happy welding! Executive summary. Here's a summary of SMAW shielded metal arc welding process fundamentals. Principle: SMAW, also known as stick welding, uses a consumable electrode covered in flux to produce an electric arc that melts and joins metals. Equipment: one SMAW power source, provides electrical energy for the arc. 2. Electrode holder, holds the electrode in place. 3. Shielding gas, not required as the flux on the electrode provides shielding. 4. Welding helmet, protects the welder's face and eyes. Process variables. 1. Current, controls the arc's heat input and penetration. 2. Voltage, controls the arc's length and stability. 3. Electrode angle, affects the weld's penetration and appearance. 4. Travel speed, controls the weld's width and thickness. Electrode types. 1. Rutile electrodes, general-purpose electrodes for mild steel. 2. Basic electrodes, used for welding high-strength steels and low-alloy steels. 3. Cellulosic electrodes, used for welding thin materials and out-of-position welding. Welding techniques. 1. Forehand technique, welding with the electrode pointing in the direction of travel. 2. Backhand technique, welding with the electrode pointing opposite to the direction of travel. 3. Push technique, welding with the electrode pushed away from the welder. 4. Pull technique, welding with the electrode pulled towards the welder. Safety precautions. 1. Wear protective gear, welding helmet, gloves, and safety glasses. 2. Ensure proper ventilation, prevent inhalation of fumes and particles. 3. Use proper electrical connections, prevent electrical shock. 4. Keep the work area clean, prevent fires and tripping hazards.
Here's a summary of the essential equipment for SMAW shielded metal arc welding. 1. Power source type, AC or DC output, 50 to 500 amps duty cycle. 20 to 100% features, voltage regulation, current control, and overload protection. 2. Electrode holder type, insulated or non-insulated size, varies depending on electrode size. Features, comfortable grip, secure electrode retention, and electrical insulation. 3. Electrodes type, rutile, basic, or cellulosic size, varies depending on application. Features, flux coating, wire core, and packaging. 4. Welding helmet type, fixed shade or variable shade, 10 to 14 features: UV protection, impact resistance, and comfort. 5. Welding gloves material: leather, synthetic, or hybrid. Size varies depending on hand size. Features: insulation, grip, and durability. 6. Safety glasses type: prescription or non-prescription, shade, clear or tinted. Features: UV protection, impact resistance, and comfort. 7. Fire-resistant clothing material: cotton, polyester, or aramid. Features: flame resistance, heat insulation, and comfort. 8. Welding table or workbench material: steel, wood, or composite. Size varies depending on application. Features: stability, durability, and adjustability. 9. Vise or clamping system type: mechanical or hydraulic. Features: secure workpiece retention, adjustability, and durability. 10. Cleaning and maintenance equipment type: wire brush, sandpaper, or chemical cleaner. Features: effective cleaning and maintenance of equipment and workpieces. Here's a summary of equipment setup and operation for welding. Equipment setup. 1. Power source: connect the power source to a suitable electrical outlet, ensuring the voltage and amperage match the welding process requirements. 2. Welding machine: connect the welding machine to the power source, following the manufacturer's instructions. 3. Electrode holder: attach the electrode holder to the welding machine, ensuring secure connection and proper electrode alignment. 4. Workpiece: securely fasten the workpiece to a welding table or workbench, using clamps or vices as necessary. 5. Safety equipment: ensure the welder is wearing proper safety equipment, including a welding helmet, gloves, and safety glasses. Operation 1. Pre-welding checks: verify the equipment is in good working condition and the workpiece is properly prepared. 2. Striking the arc: hold the electrode at a 20 to 30 angle, lightly touching the workpiece, and strike the arc by quickly moving the electrode away. 3. Maintaining the arc: adjust the electrode angle, travel speed, and arc length to maintain a stable, consistent arc. 4. Welding technique: employ proper welding techniques, such as forehand, backhand, or push-pull, to achieve desired weld quality. 5. Post-welding procedures: allow the weld to cool, inspect for defects, and perform any necessary post-welding operations, such as grinding or cleaning.
Safety considerations. 1. Electrical safety: ensure proper electrical connections, avoid overloading, and use electrical insulation as necessary. 2. Fire safety: keep the work area clean, remove flammable materials, and have a fire extinguisher nearby. 3. Personal protective equipment: wear proper PPE, including a welding helmet, gloves, and safety glasses to prevent injury. 4. Ventilation: ensure adequate ventilation to prevent inhalation of fumes and particles. 5. Regular maintenance: regularly inspect and maintain equipment to prevent accidents and ensure optimal performance. Conclusively, here's a conclusion on shielded metal arc welding SMAW. Shielded metal arc welding SMAW, also known as stick welding, is a widely used welding process that offers numerous benefits, including 1. Versatility: SMAW can be used to weld a variety of metals, including steel, stainless steel, and cast iron. 2. Ease of use: SMAW is a relatively simple process to learn and master, making it a great choice for beginners. 3. Low equipment cost: SMAW equipment is relatively inexpensive compared to other welding processes. 4. Portability: SMAW equipment is lightweight and portable, making it easy to take to different job sites. However, SMAW also has some limitations, including 1. Limited precision: SMAW can be difficult to control, making it challenging to produce precise welds. 2. Slag removal: SMAW produces slag, which must be removed after welding, adding an extra step to the process. 3. Limited thickness range: SMAW is best suited for welding thinner materials, as it can be difficult to penetrate thicker materials. Despite these limitations, SMAW remains a popular choice for many welding applications, including 1. Construction. SMAW is often used in construction to weld steel beams and other structural components. 2. Repair and maintenance. SMAW is commonly used for repair and maintenance work as it is easy to use and requires minimal equipment. 3. Fabrication. SMAW can be used for fabrication work, such as building custom machinery or equipment. In conclusion, shielded metal arc welding SMAW is a versatile and widely used welding process that offers many benefits, including ease of use, low equipment cost, and portability. While it has some limitations, SMAW remains a popular choice for many welding applications. See you again in the next lesson. Happy learning, folks!